the importance of units / unit analysis. Okay, so why are units important in physics? The unit is basically, call it an identity. The identity of a measured quantity. What that means, well, one analogy you can use is units equal last name. Number equals first name. Okay, so with my name, Dustin Oncolade, the equivalent for, let's say, my name, okay, and then the name of the max speed of my car. So that's what we're going to compare, I guess. My name, just Dustin Oncolade, the name of the max speed of my car, I don't know, on the speedometer maybe it says like 140 miles per hour. Sorry, I did that wrong. 140 miles per hour. Okay, so really, this looks bad. So really what we see is that this number tells us size, and this tells us, I mean, really the number's identity. The identity. What it is. Alright, whereas the last name tells you family, where you come from. And the first name just gives you what people can call you. So if someone asks me what is the maximum speed of my car, I could just say, well, no, I'd need to say 120 miles an hour, because if I just said 120, well, what am I talking about? I guess if we're both in America, then it's probably going to be assumed it's miles per hour. But if I'm talking with someone else elsewhere in the world, then units become necessary, because we're not talking in the same mathematical language. Most of the rest of the world uses metric. Science uses metric system, but US doesn't. So what I'm showing you here is, I mean, it's important, like your family name is important and part of your name. Sure, you focus more on the first name. Yes, you focus more on the value, the number. That's what you have to put into the calculation and calculate. But if you are in the habit of leaving out numbers and you encounter anyone at all that, and you actually have to encounter, or somebody sees your work that doesn't directly know exactly what you're doing, then they're probably going to make assumptions that you may or may not agree with. So just like if you're talking about the speed of your car to someone living in Europe, and let's say you're vacationing in Europe and you're talking about your car going 120, and you don't specify you're talking about miles an hour, you can pretty much assume that that person is going to be thinking kilometers per hour, and you will have a misunderstanding. So instead of thinking of instead of thinking of different countries, think of anybody not in your physics class. Maybe a physics student at a different school. Maybe just a non-physics student. Maybe someone that's trying to help you, and they've taken physics elsewhere, somewhere else. Anytime you're trying to communicate with someone who doesn't already exactly know everything about what your assignment is and what parameters you use, they're going to have trouble understanding you. So, I mean, if we're looking at why use units, the big why, I mean, it's communication. The reason I want you to use units because I want you to communicate scientific ideas clearly. And there's a couple ways to do that. The first one is show all mathematical steps to solve problems. Use all mathematical steps to solve problems, or show them, and make them look organized. You know, A equals delta V over delta T. If my A is 12 meters per second squared, and that equals 10 meters per second over delta T, I want to show, first of all, that I'm multiplying both sides by delta T. And then the delta T's cancel. And so next I have delta T equals 12 meters per second squared equals 10 meters per second. And, equals, not equals, times. And now I'm going to divide by 12 meters per second squared. Divide by 12 meters per second squared. And I am running out of room, but those cancel. So I'm going to go and write it here. And so I have a delta T equals 10 meters per second divided by 12 meters per second squared. And let me be also extra clear. Your fraction should probably not be sideways. Sideways gets confusing. Make them up and down just like this. Okay, so now we have 10 meters per second divided by 12 meters per second squared. And, you know, we're not quite done. We have to multiply top and bottom by the reciprocal. So we're going to do that. We're going to multiply top and bottom by seconds squared over meters. Seconds squared over meters. All right, and then we can see from here that seconds squared is here and here. 12 meters cancels here and here. Seconds cancels from here and here. Meters cancels from here and here. And we're left with 10 divided by 12 seconds. 10 seconds divided by 12. Or 0.83. 0.83 seconds. So right here I showed you how to communicate scientific ideas clearly through the mathematical process. All right, and I've also gone over the process of doing some unit analysis. And now I'm going to go to the next step to communicate clearly. Put units on all non-ratio numbers. And what that means basically is anything that is measured has units. All right, and a ratio would be any kind of fraction you see in an equation. And you haven't seen one yet, but an example later on would be KE equals 1/2 mv squared. This number would be the ratio because it is unitless. All right? All these other things, they're based on, those things have to be measured. And if they're measured with instruments and they are real, so you need to say what an m is so that you know the difference between mass, kilogram, and v, which has units of meters per second. I'll do it like this because it looks like the graph. So, to communicate, the last step in communication is going to be draw diagrams. All right, if you want to communicate your ideas clearly, the next thing you do is draw diagrams. And let me review the different conventions for drawing a diagram. If you have an object falling, then I'll draw an object and it's falling. It's got to fall from a certain height. So I will call this its height. I will give it ground. All right, and this object, if it's falling, it has an initial speed, v initial. All right, and if it's falling, when it reaches the bottom, oh, I don't want to put the v initial there, sorry, v initial. When it reaches the bottom, it'll have a different velocity, a v final. It reaches the bottom, but note this is right. I'm going to change that. The instant before it hits the ground. All right. And then, yeah, this is a certain height and it speeds up. Why does it speed up? It has to have something that is causing that, and that's the acceleration due to gravity, which is 9.8 meters per second squared downward. And lastly, it takes a certain amount of time to get there. So what I'm going to do is, from the ball going from this spot to this spot, it took a time t. So basically with this, I've drawn a diagram that works for any falling object. Any object falling straight down. Without air resistance. Can use this diagram. So if you have a physical situation that you're trying to describe, it will make it much easier for you to communicate your ideas if you also include a diagram. All right, so those are the three communication ways to communicate clearly. Again, I'll write that, communicating science. One, show all math in an organized manner as displayed earlier. The second one, include units on all non-ratio quantities. And non-ratio quantities would be measured quantities. Quantities that can be physically measured with some kind of device that we can make. Okay. All right, so last part of this, I'm going to show you all the units that we've gone through so far. So here's the symbols, units, and I'll make the third one the concept. It's kind of backwards, but hang with me. So delta x meters, concept is displacement or change in position. You can look at it either way, they mean the same thing. All right, now let's go with D. D has the units of meters, and it just means distance. All right, then we move to time. T, time is in seconds. Then we move on to V sub S, and the units are meters per second, and I call that speed. And then V, also meters per second. This is velocity. Okay, and then we have A, which is acceleration, and that's meters per second squared, or maybe easier, meters per second. Acceleration. So the thing to know about this is these are different. Velocity and acceleration are different. So you should never confuse the units. Meters per second squared will never ever be the same thing as meters per second. And this is your biggest tendency as students here, is to equate the two. All right, acceleration is change in velocity over time. Boy, that's change in velocity over time. All right, velocity is change in position over time. Change in position over time. And I might add that these are technically averages. Okay, so I think those are all the ideas I wanted to go through. I want to give you one more trial of working with units. So actually, I'm going to show you it all right now. So first of all, meters per second. All right, if you end up seeing any of this in your equations, this is how you deal with it. You multiply by the reciprocal. So the reciprocal of seconds would be 1 over seconds. the reciprocal, so you multiply top bottom by 1 over seconds. This equals 1. Um, 1 over seconds divided by 1 over seconds equals 1s. And then if you want, you can put the divided by 1 here just so you're clear on what's going on. And then from there, you see that these cancel and nothing cancels up here. So you're left with meters divided by seconds times seconds, or meters divided by seconds squared. Next one. We have meters per second. I think the other one would be meters divided by meters per second. Okay, so again, this is this is our main fraction. So this is like distance over velocity equals time. Do I want that? This one is velocity, distance, yeah. So this one is velocity divided by time. So that's what that one is. This one is distance divided by velocity, or let's say displacement divided by velocity. All right, that would be seconds over meters, and these are multiplied together, seconds over meters. Now this one's kind of tricky because this top one doesn't look like it has denominator. So you can give m divided by, you can give it 1. M divided by 1 is the same as m. Same thing. So you can put m divided by 1 there so you're not confused. And we see everything that cancels. And if this m is on top and this m is on bottom, then they cancel too. And we're left with seconds. And seconds matches up with time. Meters per second squared up here matches up with acceleration. Those are the units of acceleration. These are the units of time. Next one, let's go delta V over, let's see, I don't want to do that one. So A is delta V over delta T, so let's go delta V equals A times T. All right, if we deal with these units, meters per second squared multiplied by seconds. All right, well, this seconds can be rewritten seconds over 1, and then this one's a little more straightforward. The square, before I do that, seconds squared is the same thing of seconds times seconds. So when I'm going through and doing this, I am canceling out only one of the seconds. And so my numbers that are left are meters per second. Okay, so now I'm going to want you to try. So clear that, and number 1. All right, so I want you to try meters divided by meters per second. And this would be delta x over v equals t. Number 2, you will try meters per second divided by meters per second squared, and that is also t, but it's t equals delta v over a. The third one you'll do would be meters per second multiplied by seconds, and this is v times t equals delta x. And let's try a different one with different units. You use the same mathematical processes, but they're just letters that you haven't seen yet. So you should try kilograms times meters per second squared. That one's kind of an easy one. And this is an equation we'll learn soon. F net equals ma. And then we'll say kilogram meters per second, this is a hard one, divided by kilogram meters per second squared. And what will that equal? All right, and this one is delta P over delta F equals delta T. So you should be getting a time here. Anyways, those are your 5 problems for this. Do I want to give you problems for anything else I taught? I taught about the ratios, about communicating scientifically. No. These are them. This is the work you have to show me in order to show me that you got the points. And I don't expect to see answers here, just answers. I expect you to show me the math. Show me how you multiply by 1 and cancel things out. All right, that's it.